In this video, we're going to take a look at an application of finding absolute maxes and absolute mins. So these type of application problems are typically called optimization problems. And there's not really a nice set of steps that you can follow for every single word problem because they change so much. But here's sort of a guideline for solving them. First of all, you definitely want to identify what it is that you're trying to maximize or minimize, and then get a function for that in terms of just one variable, and make sure that you define what that variable is. Once you've determined that function that you're wanting to find a max or a min for, next determine whether that function exists on an open interval or a closed interval. So are there restrictions on your variable which allow for a closed interval, which means that you would use the finding critical values and the y values to determine the max or min? Or is the variable defined on an open interval, in which case you would need the critical value and the second derivative test in order to determine the max or the min? And then, of course, after doing all of that, make sure that you write down what the actual answer to the questions being asked are. So let's take a look at this example here. When a management training company prices its seminar on management techniques at $400 per person, they get 1,000 people to attend. So now, as I am reading through this problem, I'm going to jot down information that I might need to do the solving. So the first thing was, we know that at a cost of $400, so my cost is $400 per person, that yields 1,000 people attending. And then the next sentence says that the company estimates that for each $5 reduction in price, an additional 20 people will attend. So for each $5 reduction, we will yield an additional 20 more people. And the question is, how much should the company charge for the seminar in order to maximize revenue, and what will that maximum revenue be? So we know that we are wanting to maximize revenue. So just jotting all of that down, now I know I need to just come back to this information as opposed to having to go back into the word problem and start reading through it all again. So the most important thing right now is we know what we're trying to maximize or minimize. We want to maximize revenue, which means that's the function that I need to create. So if we look at, for revenue, what I might want to do first is, in words, describe what revenue is and how I calculate it. So the revenue is all of the money that I'm going to make. And of course, the money that I make on this seminar is going to depend on the number of people who attend and what the cost for each person to attend is. So I could write this revenue down as being the number of people attending the seminar times the cost per person to attend, so the cost to attend. So if I stick with the cost of $400, then I know 1,000 people will attend, so I know my overall revenue would be $400,000. But here's where we want to change it. When we're coming up with what this function will look like, we need to consider that we're trying to decide how many of those $5 reductions to make. Because I know if I reduce it by $5, I get 20 more people, which is going to increase my revenue. But at some point, if I increase it, or if I decrease it too much, I might start losing money. So we're trying to find that sweet spot of reducing the cost, but maximizing my revenue. So the variant here is how many of those $5 reductions to have. So that tells me that that's my variable. That's what I'm going to play around with to find out my answer. So I can define my variable now. I can say that I'm going to let x equal the number of $5 reductions. And now what I want to do is create an actual revenue function mathematically instead of in words. So I want to create a formula for this revenue based on the X, so based on the number of $5 reductions. So that means that I need to translate the number of people attending into an expression containing X. So if we start with, we know we're going to get 1,000 people, and we're going to add to that 20 more people for every $5 reduction that we make. And every $5 reduction we make is represented by X. So if I make only one reduction, one $5 reduction, I get 20 more people. If I make two $5 reductions, I get 40 more people. So I'm going to get this many more people based on that number of reductions. Next, I want to move to creating an expression for the cost to attend. So my cost to attend we know is $400, but then we're going to take off a certain number of $5. So we're going to take off either $5 if I only do one reduction. I'm going to take off $10 if I do two reductions. So I need to multiply this 5 by however many reductions I'm going to make. So now I have a clear formula for my revenue. Now, once I have that function for my revenue in terms of X, I want to determine if this interval is open or is this a closed interval. So in other words, I want to determine whether there are restrictions on my X. So think about what we want. This function is revenue. So in general, I definitely want my revenue to be a non-negative amount. I don't want to lose money. So I do know this. I want my revenue to be greater than or equal to 0. Hopefully it's not 0, but in some cases it might be okay to break even. So we're going to have our revenue be 0 or be greater than or equal to 0 and figure out what that means in terms of X. So I want to set my revenue function, which is 1,000 plus 20x times 400 minus 5x, to be greater than or equal to 0. So this is already in factored form, so I can split these factors and solve each one of them for my limits on X. So if I solve this, I subtract the 1,000 and divide by 20, I get X is greater than or equal to -50. And now think about what X is. X is a number of reductions. We can't have a negative number of reductions. So not only does it have to be bigger than -50, we can actually pull that up and say X has to be greater than or equal to 0, because it doesn't make sense to have any negative values for X. Now in the second inequality, when I subtract 400, and then I'm going to divide by -5. So remember, anytime you divide by a negative, that flips your inequality. So I get X is less than or equal to 80. So we have some restrictions on X that say X must lie between 0 and 80. So this is an absolute max or min problem on a closed interval from 0 to 80. So knowing that this interval is closed sort of dictates what my next step is. So for a closed interval, I want to find the y values for the endpoints of that interval and any critical values that lie in that interval. So my next step is going to be to find what those critical values are in that interval. So remember, my function is here. So to find the critical values, I need the derivative of that. And you could, if you wanted, you could multiply these out, clear your parentheses, and then do your derivative. Or I can use the product rule. And so I'm just going to use the product rule. So the product rule says you leave the first one alone, times the derivative of the second, which would be -5, plus we leave the second one alone, times the derivative of the first, which would be 20. So there's my derivative. And now to find the critical value, I have to set that derivative equal to 0 and solve for x. So I'm going to set it equal to 0, and I'm also going to clear my parentheses. So I'm going to distribute this -5, which would give me -5,000 minus 100x. And here I'm going to distribute the 20, so that would give me plus 8,000 minus 100x. So combining some like terms here, I'm going to have -200x plus 3,000. And then subtracting the 3,000 and dividing by 200, I get x is equal to 15. And I want to check that 15 does lie in my interval, so it is a number that I want to consider as a relative max. Now, to find out, our relative max is either going to occur at 15, at 0, or at 80. So to figure out which one it is, I want to create a little bit of a chart here. I'm going to keep my function on my screen. So the chart that I'm going to create is going to contain all of the possible x values and what my actual revenue is at that particular x value. So the x values that I have to consider are the two endpoints, 0 and 80, and my critical value in those endpoints of 15. So I'm replacing this 0 back in the original function. So if I put 0 back into, this is my original function here, and let x be 0, I'm going to get 400,000 for a revenue. So that was with no $5 increases, or reductions, I'm sorry. If I plug in 80, well, if I plug in 80 into this, that was one of my numbers here, so I'm going to get 0. And if I plug in 15 everywhere I see an x up here in my original function, I get 422,500. And remember, I'm trying to maximize my revenue, so I want the one with the biggest y value or the biggest revenue, so that would be that one there. So we've got an answer to our question. Now don't forget what x is. X isn't my cost. X was the number of $5 reductions that I want to make. So what I'm going to do to answer this question, which was what do I charge to maximize revenue, remember that we charged $400, but we are going to reduce that price by 15 $5 reductions. If you go way back to the beginning up here, we had the cost to attend, we had the cost to attend defined by that expression, 400 minus 5x. So all I'm doing is putting in the 15 there in order to figure out what my cost is going to be. So my cost is going to equal $325. So that's how much I want to charge to maximize my revenue. And my max revenue will be, that's the y value. So my max revenue will be $422,500. So there's the answer to the question.